Welcome back, Algebra 2 students. Today we're going to do lesson 2.1 on the vertex form of a quadratic function. So part of this section will be review. We're going to look back at the form that we used when we talked about transformations. And you're going to learn how to change that form into this form that you see here, ax squared plus bx plus c. So there's different ways of writing a function. This is one of them, okay? And the other one that you're more familiar with from the previous section is the f of x equal to a times the quantity x minus h squared plus k. So all of these quadratic functions are transformations of the parent function, which is f of x equal to x squared. The graph, remember, is called a parabola. From this form, remember, we can easily identify the vertex. That's why it's called vertex form. And that vertex is h comma k. So again, this form is useful because when it's in this form, immediately we know the vertex of that parabola. So for the parent function, remember, it's at the origin, and that's the point that we usually focus on when we're doing the transformations. So here, how are transformations of the graph of f of x equal to x squared related to an equation representing another quadratic function? So do you remember from our transformations, what do these numbers do to the graph? Okay, so if you're saying that this would shift it to the left, that's correct. Remember, horizontal shift is opposite of what we would think. Right, so even though this is a plus 2, it's going to the left 2 units. That negative 1/2, okay, there's two things happening here. The negative makes it reflect over the x-axis, and the 1/2, that's our vertical compression. Which means the graph, the y values are going to drop, right, from where they would normally be. We're taking half of all those y values and we're reflecting them over the axis. Okay, part B, how are the transformations of, again, x squared related to this equation? So take a minute if you want, pause the video, come back and we'll talk about it. Okay, so the -1, that's shifting the graph to the right 1 unit. The -3 on the outside, that's down 3. And the 2, this is now a vertical stretch. Think of it as we're taking all the y values and multiplying by 2. So they're going to get higher faster, right? Or larger faster. So the graph is stretching vertically. Example 2. So what are the key features of this graph? So we're going to look at all of these things. So again, that vertex form, there's my h comma k. That's my vertex. Okay, so the vertex is 3, 4. Now if you're saying, well, wait a minute, why isn't it -3? Remember, that horizontal shift is opposite of what we think. The standard form is with the negative. It's f of x equal to a times x minus h squared plus k. So when this is a minus, the h value is the +3. If this were a plus, then the h value will be a negative. So our vertex is 3, 4, and it goes 3 to the right, 4 up. Our a value is 2. And what does that do to the graph? It's a vertical stretch. The domain. All of our parabolas will either open upward or downward. So in that case, the domain is all reals. Remember to use your interval notation. The range, however, that will change all the time, depending on how the graph is shifted. right? If it's shifted up or down or reflected. So the range, we start from minimum y value, which is 4. We include that value, and then it keeps on going up. So it's 4 to infinity. The axis of symmetry, that's the line that divides the parabola in half. It goes right through the vertex. So the x value of that vertex is how we write the equation of the line, right? All vertical lines have the form x equal to a, where a is the number that it crosses through on the x-axis. So if my vertex starts with a 3, 3, 4, then my axis of symmetry is the line x equal to 3. So again, whatever's the x-coordinate of your vertex, which would also be the same x value that the line's going to go through on the x-axis, if you extended it, x equal to that number gives you your axis of symmetry. Example 3. So what is the equation of a quadratic function with the vertex of -2, 3 and a y-intercept of -1? So now we're going to do the reverse. We're being told the vertex, and we're also being told a point that's on the graph. We are going to come up with the equation. So if I start with my general form, or I'm sorry, my vertex form, don't forget that square, that's important. What we're going to do is plug in the values. So remember, the vertex is h, k. So that gives me the values of h and k. The y-intercept are the points x, y. So that means x is 0, y is -1. Remember, f of x is a replacement for y. So I can replace it with the value of -1. A is the one we don't know. That's what we're going to solve for. My x value is 0. H is -2. Make sure you have the minus here from the original form. So it's a minus -2, and don't forget that square. And k is 3. And now I can calculate a. So I have -1 is equal to, or we do inside parentheses first. So minus -2 is a +2. Not that it matters, because whether if I square -2 or +2, I'm going to get 4. So the square comes next. Remember your order of operations, PEMDAS. So we do inside the parentheses, then we do the exponent. So 2 squared is 4, so I get 4 times a, and then plus 3. Next, I am going to subtract. I want to get that 4a by itself. So I have -4 is equal to 4a. So a is equal to -1. So that was my whole goal, was using these 2 points to plug in for h, k, x, and y, solve for a, and now I've done that. I know my a value, so I can rewrite the function in the standard form using -1. Now I'm just going to put a negative. We don't usually put the 1 there. Remember, 1 is understood. X minus h, so minus a negative, is +2, and then plus k, and k is 3. So there's my vertex form of the parabola with this vertex that has a y-intercept of -1. Okay, so I want you to try this additional example 3. Pause the video, give it a try. This is your vertex, so remember this is h and k. It goes through this point. So it's the same as the other one, except it's a little bit harder because it's not a y-intercept. Your x isn't 0, but this is x and y. So plug into your form. Start with all the variables. Don't forget the square. Plug in, solve for a, and then rewrite it in its final vertex form. Okay, so pause the video, come back when you're done. Okay, let's see how you did. So I plugged everything in. I got -3/2 for A. So here's my final form. If yours differs, compare the work. If you think maybe I did something wrong, let me know in class. Okay, example 4. So we have the height of a ball that's thrown is a quadratic function of the time it has been in the air. So the graph of the quadratic function is the parabolic path of the ball. Right, so it's going to have that, the ball goes up and then it comes down. It's going to have that parabolic path. The vertex is 120. So what does that mean? Think about it. It's the function of time that it's been in the air. Okay, so if this time is in seconds, that means after 1 second, then the height of the ball is 20 feet, if this is in feet. I don't think they give us units here. Okay, the path of the ball includes the point 0,4. So what would that mean? That means at time 0, the ball is at 4 feet, which would make sense, right? If you're holding the ball, it's possible that it could be 4 feet up in the air to begin with. So what is an expression that defines this function? Write the quadratic equation in vertex form and then in this form. So let's start with the vertex form. So we have f of x equal to a x minus h squared plus k. So they give us the vertex, that's our xy, so y is 20. X is 1. And then, oops, I'm sorry, that's our hk. My gosh. They give us the point 0,4. Sorry about that. So y is 4, x is 0, h is 1, and k is 20. Okay, so again, the vertex, let me just clear that up, is always h comma k. The given point is always x comma y. So solving for a, -1 squared is 1, so it's just a 1a plus 20. So subtracting a, I get -16. So that's my a value. So our vertex form is -16 x minus 1 squared plus k, and k is 20. Okay, that takes care of vertex form. And now we're going to put this into this form. So what we have to do here is actually multiply this out and then distribute the -16 and combine the constants. So if you remember, let's do a little side work here. X minus 1 squared, that's the first thing we're going to do. That means x minus 1 times itself. So we can do FOIL. Remember the inners and outers get combined. So that's -1x minus 1x, which is -2x. And then -1 times -1 is a +1. So it becomes -16 times this trinomial. Oops. And then on the outside, I have the +20. So my next step is to distribute the -16. -16 times -2 is a +32. -16 plus 20. So when I combine the constants, here's my final answer. -16x squared plus 32x plus 4. Okay, so here's the vertex form. And here's the ax squared plus bx plus c form. And both of these are very useful forms, so you do need to know both of these. Okay, let's take a look at example 5. Oops. Let's see. In your notes, you should have an example 5. Sorry. I'm gonna stay on this page when you are done. I wanted you to do example 5. I didn't leave the blank one here on my notes for some reason, but I want you to try example 5. So pause the video, see if you could come up with, again, both forms. So start with the vertex form, multiply out this quantity, right? So this quantity by itself, and then distribute, like we did here, and combine constants and get the second form. So go ahead and try example 5, and then when you're done, come back and we'll go through it together. Okay, let's see how you did. So here's my example 5. So we have the function is going 1 to the left and 3 up. So that gives us a +1 and +3. Okay, so we need to solve for a. We can also see from the graph that 0, 4 is a point on the graph, right there. So since we can identify that point, we can use it for our xy. So y is 4, x is 0, and then calculating a, we get a is equal to 1. Substituting that into the equation, we get, or we wouldn't put a 1 here, it's understood. So we just get x plus 1 squared plus 3. And again, squaring x plus 1, very similar to the last one. Notice the only difference here is the sign, because this was an x minus 1 squared. So this was x squared minus 2x plus 1. When it's a positive 1, it becomes x squared plus 2x plus 1. And then adding the 3 from the k value, we get a +4. So here's the ax squared plus bx plus c form. And this was our vertex. Oh, this one's our vertex form. Okay. Lastly, we have a concept summary. So I'd like you to read through this, make sure all of this makes sense. Okay, so just skim over it real quickly. Make sure everything makes sense. If you have any questions, put a little star next to something or highlight it, okay, and ask about it in class. But everything at this point that you're seeing, you should be very comfortable with. So that concludes our lesson for 2-1. I hope you enjoyed it, and I will see you in class. Have a good day.